In 1980, 3 siblings were each given $1,000 as part of the inheritance from a deceased uncle. The siblings agreed to invest their money individually and come back years later to see who would amass the most fortune. Just like siblings, right? Yeah. The oldest brother, Alan, put the $1,000 into the bank. Each month he would add $62.50 to the account, or $750 per year. The sister, Bernice, invested her $1,000 in various money market accounts and earned 12% interest each year, which is compounded annually. Carl, the youngest, put his money into technology stocks. Their value climbed according to a parabolic curve until it peaked at $20,600 in 1994. By 2008, the stocks had fallen back to their original value of $1,000. So first thing it asks us to do is determine which sibling's financial history matches each graph above. And then how can you tell? So which goes with which?
Carl's is the quadrant.
Carl's is the easiest one to figure out, right? Because it tells you. Right? Okay? So Carl is the parabola, which is also kind of called what kind of function? Quadratic. Okay? And how can we tell? Besides the fact that it says
It said it rose and then
it rose and then it fell. Fold? I don't know what I'm saying today. Fell. Okay? So that kind of gives us an indication of the 3 choices that it would have to have risen and then fallen. Okay? What else do you know?
Alan's
Alan is
Alan's is going to be the line.
Yeah.
Why?
It's the same amount for something at a time.
It's the same amount, like a constant amount, right? Okay, that he's adding every time. All right, so that means Bernice must be, don't say the other one. What is the other one? It is. It is exponential. Okay? So here we're going to let x equals the time in years since 1980. Write function rules to determine how much money each sibling had after x years.
Alan is 750 years.
Why would you write Alan's first?
It's at the top.
Just because it's first in the list?
Yes.
Probably it's the easiest, right? We already decided it's linear. That's pretty easy to do. We have to know where it started, and we have to know how much it changed per year, right? Wait, per year, or how much he deposited? Like each time? Does it matter? What is x representing?
The amount of
Years. So it does matter, right? So what do you think our equation is for Alan?
750x plus 1,000.
Perfect. 750x plus 1,000. Okay? Which one do you think is next easiest, Bernice or Carl?
Carl.
You think Carl's the next easiest? Okay, so go ahead and tell me the equation of his parabola. Because, I mean, nobody ever asked me, but if they did, I would think Carl's would be the next easiest to write. Because I know he started with $1,000, and I know it increased, excuse me, how about if I say Bernice? Do you mind if I say Bernice? She started with $1,000, and she earned interest at 12% each year.
Yeah, that's easy.
So what goes here in the parentheses?
1 plus 0.12.
1.12, yes. Okay. And then what?
To the x power.
To the x power. For the record, Carl is my granddad's name. I liked him. So I always wanted to write his first, even though it's not the easiest. Okay? So what do you got? I'll give you a little bit of a break here because it has been a while since we've done quadratics. Okay? How many points does it take to write the equation of a parabola? At least 3. Okay? At least 3. 2 for a line, at least 3 for a parabola, right? Do we have 3 points in this parabola?
Yeah.
Or in this explanation?
Yeah.
We do, right? So probably the easiest way for us would be a regression, wouldn't it? So let's remember how to get the equation of regression. I'm going to zoom in just a little bit so you can see this a little bit better. We need to add a list in spreadsheets. And we know our x value is going to be years. And we know our y value is going to be what? Wait, what is our y value going to be?
Amount of money.
Money? So what do I know? What points do I know? You said I had 3. What are they?
0, 1,000.
0, 1,000? Because why?
Because he started off with $1,000.
You started off with $1,000 in 1980, right? What else do I know?
14, comma.
Whoa, whoa, whoa. Nowhere in this problem do I see 14.
It's the
It's the
What do I see?
since 1994.
1994,
That's
right?
what it
That's
is.
what I see. And it tells me very clearly right here that X is the time in years since 1980. Well, 1994 would be 14 years later, right?
14, comma, 20,600.
20,600. And do we know any more?
Yes.
What do we know?
28, comma, 1,000.
28, 1,000?
That would be pretty bad. You get all those 20,000.
That happens. Sometimes this last one is 0 or worse, right?
You know
Negative.
You know when you got it back out.
Okay. What do I do now? Once that I have it into the statistics page, what do I do?
You add a new page.
Add a new page.
The graph.
That is
I forgot the name.
data and statistics, right? I had it in the spreadsheet. So now I need to go and assign variables. I got to move my cursor down here to the x-axis. What should be on the x-axis?
Years.
Years. And what should be on the y-axis?
Money.
Money. And now we press menu, analyze, regression. What kind of regression are we asking for?
Quadratic.
Quadratic. Okay, is this the only way to find this equation? No, there's several other ways. I don't remember if we talked about it here, but you can do it with a matrix. Okay? But this is probably the quickest way for us to get to our information since we're trying to work on it now. Okay? So we have our equation, and it is negative 100x squared plus 2800x plus 1000. Okay? Use the equations, check the equations using a graphing calculator with a domain of 0 to 28. So I'm going to go ahead and add another page that is a graph. I'm going to go ahead and put all these equations in here so I can check them. So 750x plus 1000 is the first one. 1000 1.12 raised to the x power, and then negative 100 x squared plus 2800 x plus 1000. Mine doesn't look like anything on the paper. I clearly did it wrong. I should quit.
No.
I'm glad you see the smirk on my face. But that's what I hear sometimes from you guys, right? What do I need to do? Pardon? I got to change my window. That's exactly right. Okay? So now it tells me specifically it wants my domain from 0 to 28, right? So let's go ahead and make my window. Wait, which one's domain? X. That was so exciting. I'm so proud of you for knowing that. So 0 to 28. What should we make our y's? Because see, mine still doesn't look like that.
0 to 20,000 or 25,000.
Could you use context clues on this page to figure out what your y should be?
Yes, ma'am.
Where are they?
On the graph.
On the graph. See what the graph is already given?
30,000.
So we use 0 to 28. We want to go from 0 to, what'd you say?
30,000.
Well, the graph looks like it goes to 20,000, but I know I've got to go a little bit further than that because it goes above that line.
And then the 25 looks like the B
So
line goes over.
25,000, maybe?
The B line.
That looks pretty close, doesn't it? Yeah? Now I know it's a different shape. This is not a square and this is a square, but we can probably get over that a little bit, right? Okay. So let's fill in the table. How could we fill in the table? Well, we could say x is 5. 5 times 750 equals blah, 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 plus 1,000, and write that down. Or we could do Control T and look at the table, because they already did it for us, right? So when x is 5, it's 4750, 1762.34, and 12,500. When x is 10, what could I be doing instead of what I'm doing right now? Any guesses? I could have changed my scale on my table, right? To go by fives. But this isn't terribly difficult, is it? So I need to go to 20 now. You guys are confirming my answers, correct? Of course you are.
I feel like you're gonna mess up on purpose.
I try not to mess up on purpose very often. And usually when I do, I tell you that I'm trying to trick you. Get something like that. So who has the most?
Depends which time.
I mean the first time. When x is 5, after 5 years, who has the most? Carl. After 10 years, who has the most? Carl. After 20 years, who has the most? Carl. After 25 years, who has the most? Oh, not Carl anymore. Who has the most? Ellen. Ellen. Steve. 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 I love that one. Okay. It is given that Carl had $1,000 after 28 years. How much did the other siblings have at this point? Again, is that relatively easy to figure out? Because we still have our table open, right? We just go to 28 years. How much did Alan have? After 28 years? Yep. 22,000 exactly, right? And how much did Bernice have? $23,883.87. After approximately how many years did Alan and Bernice have the same amount of money invested? Well, once again, I can just look, right? It even says use the graphs of these functions to figure it out. So how could I do that using the graph that's not the table, but the actual graph?
Find intersections.
Intersections! Yay, man, you guys are so excited about this today. So now you see why it's important to know whose is whose graph? I'm finding Alan's and Bernice's. So that is the line and the exponential function, right? So menu, analyze, an intersection. Okay, let's see. Which graph are we talking about? We're talking about the line and the intersection. Intersection. Exponential. So it's right over here, isn't it? So, after how many years did they have the same amount? What can we know? 27 years.
Alright.
And after 27 years they had? Okay, mine says 2.12 2.1234. What does that mean?
Move the decimal.
2.1234. So $21,000. $21,200 approximately. Okay. After approximately how many years did Alan and Carl have the same amount of money? Menu, analyze, an intersection. Alan and Carl, so we have the line and the parabola, right? Now, I said automatically a minute ago we were talking about that point of intersection. Aren't there two? Between the line and the exponential function? Aren't there two? Why didn't I look at the other one? Well, we know they all had 1,000 at the beginning, right? That's not what we're talking about. We're talking about after some time has passed. Okay? So this one we're talking about is the line and the parabola. So we're like here and here. So can't really read that very well, so I'm going to move it up here to the top. So it looks like 20 years, 20.5 years, 1.64E4. Same kind of deal, right? 16,400. I need you to do 7 and 8. Have a great weekend.
I have to roll my pants down so I can